Okay, so I want to talk about small drinking water supplies in the context of New Zealand and in the context of significant reforms. And I guess the key thing here is there's what we call three po of reforms, or three parts to the reforms. And the first is the setting up of Taumata Arowi, which is a new drinking water regulator, which will regulate all drinking water supplies. The passing of what we call is referred to as the Water Services Bill. So that's legislation which sets out requirements for everybody who's working in the sector, including water suppliers. And then the Three Waters Reform, which I'm not talking about today, which is a process intended to, or looking at the amalgamation of the current 67 local authority drinking water suppliers into 4 large publicly owned water suppliers. What I want to talk to you about today is the perspective and the point of view from Taumata Arowai. And the Water Services Bill is really critical to us because it's the bill that sets out what we can do. It authorises us to do a bunch of things. So it's currently waiting on its second reading in Parliament, and that's been a little bit delayed by the suspension of Parliament due to the current lockdown that we're in at the moment. And so that may delay things for us a little bit. But the bill brings all water suppliers other than domestic households under regulation. So that's a very big step for New Zealand to take. And exactly who is covered is a wee way to work through and for people to understand that. But initially we thought that there might be an additional 10,000 supplies, and then we did a bit more work and we realised that might be an extra 50,000 small supplies. And the latest estimate we have is that the number of small supplies that will be coming under regulation is somewhere between 75,000 and 120,000. Huge implications for us there. We're a very small organisation. But the bill as it's currently written says that small supplies, that's under 500, will have 3 years to register with us and 5 years to comply with the requirements in the bill. And as I said, there could be more than 75,000 supplies to be registered. What we have done is we've set up a category system for water supplies, and it has these 6 parts to it. On-demand, network supplies, trickle feed supplies. So that's like often rural supplies that receive a agreed quantity of water over a 24-hour period. Self-supply buildings where there's no network. Water carriers, so that's the trucking of water around the place. Planned event, temporary drinking water supplies, so music festivals, the like. And community drinking water stations, water carrier supplies. So community drinking water stations are where you have a place that provides drinking water that people fill containers from. And those circumstances are becoming more and more common in New Zealand. Water carrier supplies are very similar, and what they are is where a water carrier has their own bore and fills the truck from their own bore. And so we've written rules for all of these categories. The critical ones here are the on-demand, very small supplies, less than 50, and small supplies 50 to 500. And I want to talk a little bit about the rules that we've prepared for those supplies. Now, those rules need to go to a public consultation process, which we will undertake when the Water Services Bill is passed and when Taumata Arowai takes over from the Ministry of Health as the official drinking water regulator. At the moment, that's thought to be the 1st of November. The bill is hoped will pass before then, but with the current delays, who knows what will happen. But at some point, we go to a public consultation on these rules. And I'll just give you a little bit of a look at what they will be like. So this is the first time that we've had operational compliance rules for water supplies of this size. So very small supplies. The rules for all supplies are broken into 3 groups: source water rules, treatment rules, and distribution system rules. Very small supplies are going to be required to test for a range of contaminants in source water. And in New Zealand, there's been a lot of debate and discussion about source water contaminants and freshwater quality. That's a big issue, and particularly questions around nitrate and the role that nitrate plays in colorectal cancer. And more recently, there's been debate and some research about preterm birth. And so understanding the levels of nitrate in source water is very important for us. And so there's a requirement for very small suppliers to test for a range of contaminants, nitrates one, iron, manganese, boron, arsenic, those kinds of things. So treatment, where a small supplier is using surface waters, they will be required to either have a backwashable filtration process, or some selective abstraction or a sedimentation process before any further treatment. And then all sources will be required to use cartridge filtration and UV disinfection. That's the treatment. The rules are written around those treatment processes. And for distribution systems, there's some monitoring, not a heck of a lot, but there's some monitoring, bearing in mind these are very small supplies, and some requirements around backflow protection. In other words, where there's a risk of backflow, the water supplier will need to ensure that an appropriate device is installed. If we step up then to the next category of small supplies, which is 50 to 500s, very similar source water testing for a range of contaminants. It's a little bit more comprehensive than the very small supplies, but again, it's similar sorts of things. Treatment, a requirement there that there's a filtration step, media, membrane, or cartridge, and we set turbidity limits for post filtration water post filtration. The water supplies must then have UV disinfection, and they must have chlorination. So those three treatment steps are required. And then in the distribution systems, we'll be requiring some monitoring again for free chlorine, pH, turbidity, and backflow protection will be required. Additionally, there is going to be a requirement for testing for plumbo-solvent metals, and there's a range of them, but we've had some issues recently in New Zealand with high levels of lead being detected in distribution systems, and that's prompted us to set about rules for testing for plumbo-solvent metals. So that's a very rapid and basic indication of where we're going. With that, I think I'll pass back to Tom, and I'll stop sharing, and the next presenter can take over. Thank you.
Thank you, Jim. Certainly a challenging time ahead for everyone. It's a big change for everyone. And just to say to everyone, please put your questions for Jim in the Q&A box, and he'll come back to answer them once the other panelists have had a chance to speak. So now I think we're blessed with a double team of Peter Brooks and Brett Clinton, who are both at Auckland Council in the Healthy Waters Department. And they're going to talk about it from a council viewpoint. So I think it's Brett to start. Over to you, Brett.
Yes, yeah, I'm here. Good afternoon, everyone. I'm part of Auckland Council's Healthy Waters team, specifically in the small waters team, where we manage all of the on-site water and wastewater systems across the Auckland region that are on or associated with council properties. A bit of a background is that we took over these sites in July 2017, and we initiated operation and maintenance contracts for them. There's quite a range of sites. We've got around about 35 large regional parks, about 36 community halls, and then there's over nearly 200 actually toilet blocks on beach reserves or other general parks grounds. There's over 50 multi-use sites such as campgrounds, sports parks, etc. And then there's around about 50 tenanted houses and the facilities like libraries and childcare. So it's quite a range. We started off back then with quite a small team. We only had 2 full-time members, and we had significant input from a specialist consultant, Mill from Environmental. But now after 4 years, we're up to 7 full-time team members who are based right around the region in the different teams, and they've got quite a variety of skills and backgrounds. They also have other roles that they carry out, stormwater and other activities as well. Moving on to how we went about starting the process off. There were several of us in the wider Healthy Waters team that have extensive backgrounds with Auckland's large water supply operator. And essentially we wanted to adopt the same sort of principles, whereby when we do work on these systems, we do it once and we do it well, so that there's no need to go back and do any rework. And also bearing in mind, we wanted to future-proof them to an extent. The initial focus was on the water systems, which is obviously relevant to what we're talking about here. And we focused originally on the bigger sites, the regional parks and the sports grounds and campgrounds, which tended to be the riskier source. Typically they'd be on a bore or a surface type source. There's a few stream sources in the mix. And then after that, we moved on to the smaller sites with a lower risk, being the halls, and other sites where we've got rainwater, roof water collection systems. So we evaluated all these sites and prioritized them in 3 different categories. We looked at the age of the systems, the condition of the equipment, number of barriers that they might have actually presented, and what the source was, whether it was rainwater or surface bore water. On that basis, we prioritised into 3 different groups. Priority 1 sites we have mostly completed now. The priority 2s we're well on the way to, we're about halfway through that program. And then we've got the last remaining sites, which we expect to carry out over the next 2 to 3 years. Moving on to the next slide. Oh, sorry, no, there's a little bit there. Just in terms of those OPEX, CapEx and OPEX budgets, actually, we had built them up over a few years to cater for the increased amount of inspection and servicing we were doing on the higher risk sites, increased lab testing, and we were finding there was quite a lot of reactive works required in those first few years. And the CapEx budgets have been built up over that time as well to cater for the upgrades that we were doing and to build in the multi-barrier approach. So yeah, moving on. Over to Pete. He's going to talk a bit about one of those projects in particular.
Kia ora koutou, Peter Brooks Takawinga. Yeah, my name's Peter Brooks. I'm a delivery manager within Healthy Waters. Brett and I, as he's alluded to, met each other as the larger water supplier within Auckland, and I've taken a lead in this role in this project. The main work originally came around some emergency work in response to a significant dry period in December 17, after we'd only just taken over the water supplies. The local board and the Auckland Public Health Service worked together with Healthy Waters to find a long-term solution, because on Waiheke there is no network supply. People are predominantly supplied by rainwater tanks, and when the rain doesn't come, they rely on 4 commercial tankering companies to bring water to them. The format for actually getting water is actually you bring all 4, you ask them to deliver the water, and whichever one delivers it first, actually you take that and cancel the rest. So we had exceptionally long wait times, all of which we really struggled with to understand what the real problem was. And in turn, we ended up not being able to provide the most vulnerable members of our community with potable drinking water. What we did was actually prioritise a couple of centres of focus for the community. So the 2 stars on the map is actually, the blue one is Matiatia Wharf, and there's an associated car park where Auckland Council already had a bore, and the brown star is the Otatangi Sports Ground, which again is a similar site that had a bore already. And we need to do some work to upgrade these sites to actually provide community water to the people that needed it most. What we actually did was took a standardized approach, and it's a multi-barrier approach. We have in the region two types of setup within our systems, and the first one is a typical rainwater supply where people collect water from the roof. We have a first flush diverter that is stored in raw water tanks. Then it goes through the cartridge filtration of 20 and 1 micron. We did start with 5 microns as the first cut, but we actually found those became blinded very quickly, and so we actually changed that to 20. And this is a process of elimination, and what my recommendation is actually learn from our mistakes. And so we now have our standard is 20 microns and 1 micron that goes onto a UV disinfection and out to the users. The similar treatment for the bore water supply. Again, we have a pump system to drive it, obviously lift it out of the ground. Same cartridge filtration system. A duty standby, depending on the numbers supplied by the area. Certainly the 2 sites on Waiheke had this setup, and we also included sodium hypochlorite, chlorine, before we actually put it into distribution. This is actually in recognition of what we expected, a good solution, good multi-barrier solution with a residual disinfection within that. And we've really worked hard to actually get this system right, and have actually come a long way in this space. We have a hybrid of these 2 systems where we do have some bore water and rainwater supply in combination, and those sites also have the sodium hypochlorite. We just have to watch the amount of organic matter, sorry, don't want to get too technical, coming off the roof supply, because chlorine and organics don't react very well together. So just a bit of background. What we did is using that standard design for Matiatia Wharf. So that's the main ferry port, passenger ferry port on Waiheke. What we actually did was create a second treatment facility at that site with a brand new full treatment facility as described previously, including domestic and tanker filling points. These were really important to us because the tanker organizations weren't able to provide large quantities of water, so up to around 10,000 litres. They weren't able to provide that quickly enough, so we felt it was required to include those in our designs. And on Otatangi Sports Ground, we needed to upgrade the existing water treatment system to cope, and that included the tanker filling as well as the domestic filling point. Just a point to note, we haven't actually used the tanker filling points as they were designed to do yet, and this is 3 years on, and we have actually used the domestic fill points both summers, so that's 2018 and 2019, but we haven't actually used the tanker filling points because we've taken the real need for the domestic supply, so people can actually still get it if they absolutely need fresh drinking water. That has taken that need away, so it's just something to consider as you go forward. To achieve the standing up of these sites in a relatively short space of time. So I got literally the tap on the shoulder at a meeting in December 17, and by April 8, 2018, these sites were actually up and running. And to actually achieve this, we did a lot of work in parallel. And the key for that was actually understanding the water quality that was coming from these 2 sites. We actually looked at 7 sites across Waiheke. With the investigation we completed, we actually found that there was a real issue around the source water and making sure we could treat high volumes of it as we needed to when we needed to. For the application of environmental effects, which is part of our resource consent, we had a significant amount of work to do, and that work was done really early and in combination with everything else we're doing. The real key to it is understand the chemistry and the constraints of the site, making sure you understand what you actually need to do. And I'm going to hand back to Brett.
Right, so part of the task we had was to get new contracts in place and basically make sure that everything was going to be going as we had planned. So we split the Auckland region into 2 geographical areas, north west and south central, and had Morpham rights and comprehensive technical specifications and new operational maintenance schedules. And we went out to invited tenders. We went to selected tenderers who we knew had the relevant water and the wastewater experience, particularly those that we knew were based in the areas already. And as it turned out, some of them had water or wastewater contracts or both with the big operator in the Auckland region. So we knew that we were going to be able to have teams that had the wide range of skills in the specialist area, so that they would be able to mix in with their other teams and be able to tap into the wider team base that they had. And there was also the ability, if it had become necessary, which it has not, was that potentially one could cover the other area in terms of an emergency sort of situation, or at least assist in the other area. So after that process, we took on Downer and City Care for those 2 areas. The contracts were set up as 4+2+2 contracts. So we've now just come to the end of the 4-year, the first period. So part of that was we were looking for those efficiencies that we'd gained by the experience and the other teams that they had working in those areas. Next slide, Pete.
So this just gives you, coming back to the work we did on Waiheke, so just give you an idea of what these kind of treatment systems cost. So the picture on the left is at Matiatia. What is now is all of that in this one site. We actually have consolidated the 2 treatment systems that were there into one. So we got the cartridge filtration, and to the right is the top photo is at the Onatangi Sports Ground. And you can see that's the raw water tank prior to the no, it's the treated water tank, sorry, wrong way around. That's the treated water tank for post. What we've been able to do is understand the cost. So the construction of this work was around, so for Matiatia, 137,000, the actual physical works. There was 10,000 of design, 3,000 of consent, and a couple of grand of project management. Onatangi, because the Matiatia Wharf was a brand new system, don't forget. Onatangi, we actually upgraded the existing system, and there was aspects already there. So we actually used that to our advantage. So the construction work for Onatangi, sorry, my phone is ringing. The construction work for Onatangi was 124k. The design was approximately 8, consent 2, and project management just over 1. What this is really stressed to is that you absolutely need to understand the reporting requirements of the system, and actually required by that senior management buy-in. Having worked with Craig McElroy, obviously is previously his life was at the larger water supplier within Auckland, understood what we were talking about and what we needed to do. So we were pushing more against an open door than probably a lot of organisations, but you've still got to get that buy-in and understand that this is a significant investment. You're not going to get much change out of $150,000, and these are for supplies of around up to, I think these are less than 500. Matiatia Wharf slightly different, but these 2 sites we estimated on less than 500 population. So this is the smaller end of what Jim was talking about originally. Yeah, it is complex. I'm making sure that funding and adequate investment is earmarked early, and making sure you understand that is going to have to be on for an ongoing basis. As Brett's already alluded to, we've completed the priority 1 sites. We're halfway through sort of the priority 2, and we're 4 years into this. And these sites will need maintenance and ongoing stuff going forward. So make sure that you've got that longer term plan, and we've been able to build that into our budgets going forward. Just moving to some lessons learned. key ones for me is absolutely understand your abstraction and consent requirements. And that information is fundamental in actually being able to do this stuff quickly and efficiently, because I'm guessing Taumata Arowai are going to be looking for that kind of response and actually get these regulations and meeting those regulations up to speed as soon as possible. So understanding what that looks like and how to make that work is really challenging, and making sure you understand what is the amount of water you need to put through the actual site, and actually make sure you exceed that, because one of the things we learned was actually we thought we'd be supplying A, and we ended up supplying A+, which caused some real problems for us in the long term. But we actually accommodated that by picking the 2 sites we did. Over to you, Brett, about the E. coli and the total coliforms.
Yeah, so what we have seen, what we've learned from this is that we've had a progressive reduction in the transgressions that we've seen with the water quality. The lab results have be coming in better and better. And that's led to a reduction in the operational cost in terms of reactive rechlorination of some of these sites. Most of our bigger sites are chlorinated. And so therefore we're not getting that follow-up work and the lab work, the follow-on lab work that goes with that. And so, yeah, as Peter says, you know, the cost is something that shouldn't be overlooked. Both of our OPEX and CAPEX programs have continued to go up in value each year, and this year we've had the biggest OPEX and CAPEX budget funding approved so far. The other thing that we've learned is it's key to have a really good relationship with the Auckland Regional Public Health Service. We started regular meetings with them right from the start. We'd be talking about the water quality performance, obviously was their key interest, but also we were sharing with them what we were doing in terms of our upgrades. And so we've only got 2 networks. Matiatia is one of those, and we've got water safety plans approved at both of our network sites. So it is important to have a good, open, honest relationship with the regulator. And our expectation is that going forward, all of the things we've discussed here will be continuing after the bill's passed. And that the proactive relationship we have with the regulator will continue to grow. That's all really from us. So back to you, Tom.
Thank you, Brett. Thank you, Pete. Really good to hear an example of the sort of practical challenges you faced and how you overcame them. And on that, I'll hand over to our final panelist, Ben Moore, who is a director at Wavelength Water. He's going to give us a contractor's perspective on this. Over to you, Ben.
Thanks, Tom. I'll share my screen there. Right, so yes, I'm going to talk today about the small water supplies from a contractor's perspective, and that being our business, Wavelength Water. So just a quick bit of background on myself and our business. The majority of my background is in the upgrading of drinking water supplies, starting off in a council operations and projects environment, and then working through to where we are now as Wavelength Water. Wavelength essentially started in 2005, and we operate in a range of water treatment markets, including drinking water supplies, where we offer mechanical design and process design, equipment supply, installation, commissioning, and ongoing maintenance services. And I thought it may be interesting to jump into a little bit of detail around some of the challenges we see ahead of upgrading these small water supplies, particularly around the treatment system side. So first of all, some of the challenges that we see that are unique to these small supplies. I think it's worth noting who the groups that we currently deal with are, as this relates to buy-in to change being needed. In addition to councils and council contractors, we have Māori, schools, farmers, and also some volunteer groups. A general trend that we see is, although virtually everyone agrees that they need sort of safe, wholesome water, there's some vast differences in the views of what is needed in the way of planning, design, equipment, and service to make the smaller supply safe. Just some common comments that we hear, sort of around, we've never had an issue before. There's nothing wrong with our system. Why is it being upgraded? Also sort of heard comments like, what's a couple of E. coli amongst friends? But these comments aren't the majority of what we hear, but they're a significant enough proportion to take notice of. So how do we approach the challenge of buy-in? We've found that education is the key. We find the best way to improve genuine buy-in is through sharing our knowledge on what we're installing and why. Yeah, we see this creates genuine ownership of the supply, often to the point where we see people going from being hesitant or skeptical to being the strongest advocates or guardians of the system. Responsibilities, another challenge that will surely be addressed, but still doesn't seem to be 100% clear, especially with some of the more complex small supplies. We have water leaving a treatment plant, which could be fine at that point, going off through a maze of properties, storage tanks, some of which are supplemented with rainwater or other risk sources. And this basically leads to a loss of control between the source and the tap. So the challenge here is who is responsible for what part of the system. And I'm sure if I ask you guys now sort of where the lines are drawn, there could be a range of answers. Expectations, generally the source water quality of small water supplies is poorer to a degree, or at least more variable than that of large supplies. And this sort of makes sense for a small supplier. We generally use the closest source available as opposed to being able to pipe a better source from further away. But the expectations are still the same. We still need to meet the drinking water quality standards. And although this has sort of always been the case, there's no doubt that the level of monitoring required is increasing to prove that standards are being met. So we know that upgrades are coming as part of the reform, but where do we start? And I know that there'll be suppliers listening that have already made significant progress or are sort of well ahead of the game. But these are some of the themes that we've seen from a contractor's point of view. We know that there's uncertainty around the timeline and finer detail of the reform, but we do know that it's coming. So in our view, now is the time to prepare. Documentation, drawings and data are key in planning an upgrade. And we see a wide range in the accuracy and existence of key information. Quite often there are drawings of the main plant at time of construction, but if small upgrades have happened since, these often aren't captured. And we also find that the reticulation system is not so well documented. So now's the time to be surveying sites, verifying on-site to ensure drawings, etc., are accurate. Source and treated water quality results also seem like an obvious one, but often the results are only limited to the essentials. Depending on the water source, it's very helpful to have multiple tests showing seasonal variability, weather events, etc., to help build a more accurate picture and reduce the risk during design. So once this information is gathered or verified, how do we start? There's the water safety plan process, which is absolutely essential. But if we can feed some early design work into it, we find that it makes developing the plan a lot easier. And there are some differences in the approach between small and large plants. With larger plants, it's more about the process. But with smaller supplies, the products used are key. And this is because we generally condense the amount of equipment needed for a process into the product itself. Doing this lowers the cost and complexity, but it means that intimate product knowledge is essential to ensure that we meet the system requirements. Part of ensuring that the key products work as intended is utilising mini pilot trials or application testing. This testing is a fast and low-cost method compared to a full pilot trial and gives highly valuable information on real-world performance. For supplies of iron and manganese, for example, I think this type of testing is essential. From our point of view, We'd much rather work in collaboration with our customers earlier on, and it'll be interesting to see if more inclusive procurement strategies are used to help the overall reform process. So once we have a nice, shiny, compliant plant, the real challenge begins, and we need to ensure our plant remains compliant, providing safe water to our consumers. Some of the challenge here goes back to buy-in from the people involved with the supply, especially on the small end of the scale, the very small suppliers. The majority of tasks required to maintain a small system are generally quite basic, and it can be seen as an easy job for caretakers and volunteers and the like. However, the consequences of getting it wrong or missing something are obviously significant. Training helps, but these people also have other responsibilities, and expecting them to be a fully competent operator could be a bit of a stretch. I think this proactive operational monitoring is where we see one of the largest challenges compared to water quality monitoring, which is essential but generally easier to plan. Most of us would have heard of the multi-barrier approach when it comes to treatment process, but we also use the term multi-barrier maintenance, basically supporting each other and providing some overlap of duties to help ensure the system continues to perform as required. Ease and clarity of reporting is also essential. The same sort of theme applies. We aren't often using, sort of seasoned and experienced water treatment pros at these sites. So having a robust, easy to use data collection and reporting system is key to being able to prove that the system is compliant. And lastly, these small supplies are often complex, running through various properties, etc. We need to make sure that changes aren't made without a solid assessment of risk in an approval process. Regular surveys or audits would be helpful to ensure things like bypass valves aren't open, alarms muted, new connections made, like farm troughs, for example. I'm sure most of us have seen some interesting modifications out there. And with the number of supplies needing to be upgraded, we can't ignore the possibility of new technologies helping us out. We think that keeping it simple is the way to go. However, there are some adaptations on these simple technologies that can help. Backwashable filters, they've been around forever. However, there are numerous valve heads, electric or the non-electric Kinetico, for example, with different IoT connection options. The trick is selecting one that's robust and reliable. There's also a huge range of filter media options available to put in these filters, a number of catalytic options, for example, that we've put through a few further paces on some of the best water that the Waikato has to offer, and even some media options down to 0.5 microns. Ion exchange, again, not new at all, but a great option for small supplies, we think. In the right situation, they're far easier to operate with lower running costs, potentially than an oxidation filtration process. The cartridge and UV combo needs a mention, as it's absolutely essential, but I don't think I need to go into any detail around that. Lastly, chlorination, another essential tool, and in our view, on-site generation from salt actually makes a lot of sense for these small supplies, especially when you consider the people operating them may not be chemical handlers. These systems normally produce a hypochlorite solution, chlorine solution, less than 1% in strength, which is not classed as a hazardous substance like chlorine gas or full strength hypo. We need to manage the hydrogen gas produced, but that's managed through engineering controls. And on-site generation essentially removes the chemical handling risks for the operator. We have a couple of options in that area. So the online monitoring discussion, that's an interesting and ever evolving one. The Internet of Things, or IoT space, is rapidly being integrated into water treatment technology and products. But one of the challenges here with so many different products out there is ensuring a system remains open and flexible. Again, we suggest keeping it relatively simple, using products that can potentially be integrated into any other high-level compliance database or system that may be coming in future. Part of this, though, and going back to buy-in, is interaction with the users of the supply, especially the smaller and more complex ones. The more the people and users understand their supply, the more they'll protect and appreciate it. I know in our home, for example, we use an app for our power, and that's definitely decreased our consumption and monthly bill by having access to some usage information. We obviously have to draw the line somewhere, but a simple app or online portal to view a user's water consumption, see when their last service was, when the next one's due, a simple green light status assuring them that their water is safe, some sort of ideas. And this leads into what we should monitor for probably the very small suppliers, where online turbidity and chlorine analyzers might be overkill. UV system status is essential, but things like differential pressure across cartridges and UV intensity could be added at reasonable cost, and provide some really valuable operational information to help pick up issues before they actually eventuate. And finally, something that we've been working on is centralizing some of this online information collected from our customers. Going back to our multi-barrier maintenance approach, we see this as a valuable service we can provide our customers, helping them keep an eye on the operation of their system with a view to identifying issues proactively before water quality is affected. So that's it from me. I'll open things up for questioning now. Stop sharing that slide. Okay, so let's open up the Q&A section and see who's left some questions for us. So the first one from David Adamson: what's the definition of small, and what are the differences between approach between small, medium, and big? Is that perhaps one for you, Jim?
Yeah, and it's a good question. I think the first half dozen questions are probably for me. For on-demand supplies, the categories are based on the population, the number of people served. Very small supplies, less than 50. Small supplies, 50 to 500, and large supplies, anything bigger than 500. So we just use those population size categories.
Cool. Next one, Les Newman. We've set up our own village water supply. We have a treatment plant with filter, chlorine store and supply. Is the government going to take us to? Is the government going to pay us to take it over?
Yeah, interesting question. Thanks, Les. I don't think the government wants to be in the business of being a water supplier. So I think that the government won't be taking over supplies. The Water Services Bill has a provision in it where if a water supplier is failing, the local authority, Taumata Arowi, and the water supplier need to get together to figure out a solution, because a failing water supply can't continue to provide water that's unsafe to drink. And that's generally been interpreted as being that the local authority might have some responsibility to take over a water supply in that situation. But I think really this question falls into the Three Waters realm, and what happens with the Three Waters reforms. And I think that if we end up with 4 large water entities, then it's inevitable that some smaller water supplies may choose to be absorbed by those large entities if that's what they want. So yeah, I think there's a lot of discussion around that question, and it's a good question, but it's not one I can kind of answer with a very simple answer right now.
And just another one around from David there. Assume numbers of people, not households, for the different categories.
Yeah, and it is the number of people, not the number of connections. That's correct. Yeah.
Okay. Right. Which category does a marae fall into? Very small or small?
Yeah, another very good question, and we've grappled with this quite a lot. The difficulty for with marae is that you can have very rapid changes in terms of the number of people who are there. So you get an event, and there might be over 500 people. So if the population never exceeds 50, then they're a very small supply. If the population never exceeds 500, then they're a small supply. The difficulty is where the population exceeds 500, and so we've created a further category, which is what we call a varying population size. And if you are a water supply that's either a very small or small supply, and your population for short periods of time goes over that 500, there's just some extra rules. And in the past, the way standards were written, if you went over that population size, you passed a threshold which required increased treatment requirements. We don't have that. What the new rules say is that if you go past that, increase past that threshold of 500, there's increased monitoring requirements. So you've got to do more monitoring, but you don't have to upgrade your treatment system. So again, with marae, it depends on the number of people, and if you're having that varying population, then we're accommodating that with the varying population size. A good question.
Next one from Alan Evans. For small water supply, why UV and chlorination? Looks like they supply 41 houses using chlorination, not UV, and don't intend to add a sort of an expensive UV system.
Yeah, interesting question, and thanks for that, Alan. I think it's important here to recognise that there are three main groups of microbiological contaminants, if we exclude cyanobacteria, which is a little bit different. But the three main groups of microbiological contaminants are bacteria, viruses, and protozoa. We know that chlorine is a very effective disinfectant against bacteria and viruses, but we also know that it's not very effective against some protozoa. You need a high dose and a long contact time for Giardia, and it's generally considered to not be effective against Cryptosporidium, which is a form of protozoa. So chlorine on its own is never going to be enough as a disinfectant in a water supply where you might have all three of those contaminant groups. And so for small water supplies, as with any water supply, we need to have barriers to each of the contaminant groups. If you've got chlorine, you have a barrier to bacteria and viruses, but you need something else for protozoa, and UV provides that barrier to protozoa. So interesting question, and there's a little bit of technical stuff there that's means we require that multi-barrier approach.
Oh, great. Tyler McMillan, it appears the minimum treatment requirements, especially for very small supplies, have not been set based on worst case scenario. Have been set on worst case scenario. Why is this the case? And is there room for site-specific treatment solutions and risk-based approaches? Yeah,
thanks for that question, Tyler. I can see where you're coming from with this. So writing rules has its own difficulties, and one of them is that they're pretty blunt instruments. It's very difficult to write rules that have subtlety and take account of all circumstances, and it's not possible to write rules that fit best case scenarios, because then the worst case scenarios may not be taken account of. So you do need to write rules to take account of water supplies that are going to could have heavy contamination, but those rules can still work for supplies that don't have such heavy contamination. And at the end of the day, any supply needs to have a multi-barrier approach and barriers to bacteria, viruses, and protozoa. So that's the way they've been written. It's very difficult to write rules for site-specific treatment solutions as such. You need to set some bottom lines with your rules. However, that doesn't mean that you can't have some site-specific treatment processes for different things. So, for example, we don't have rules about how to treat for iron or manganese, and there's a number of treatment processes there, and I think Ben mentioned different media systems that you can use as opposed to oxidization treatment systems. So we don't specify that, and that would be a site-specific treatment system. And as well, when we specify cartridges and UV treatment processes with small supplies, we don't specify or determine what could be upstream of that. And so roughing filters might be required, and the water supplier can work out with a provider what those would be. So to say that we don't have room for site-specific treatment solutions is not really correct. We do, but we set minimum requirements for treatment processes. So yeah, thanks for that question, Tyler. It's an interesting one.
One from Jeff Dawson. Why aren't US EPA validated systems included as an option for small water suppliers?
Yeah, and Jeff, somebody's asked me this before in an email, and it may well have been you. The simple answer is the version that's been released of the rules pre-Christmas didn't include US EPA validation for UV systems for small supplies. I've changed that, and when we release a further version for people to see, and then in the consultation period, you'll find that US EPA validation is accepted. It was actually just an oversight on my part, to be honest. But what I would say here is that when we go to public consultation, I'm very keen to hear back from people like Jeff and others who look at these rules, and I'm very keen to hear from you what you think is workable and not workable, and then I'll know about what adjustments I need to make. So yeah, and that's one of them, and I've already made that one. Thanks.
Great. So a couple of questions have been bumped up the list from votes there. So what kind of assistance will Taumata Arowi seek from local authorities to identify small private water supplies for registration?
Yeah, so that's a question from Kirsty, I think.
Kirsty McLeod, yeah, sorry.
Yeah, so yeah, interesting situation coming up with small suppliers and local authorities. So the Water Services Bill has a requirement for water suppliers to undertake a kind of a survey of small non-council suppliers in their area. So they've got a really good understanding of the water suppliers out there. So that could be quite a big task. What I'm currently working on at the moment with CIP, Crown Infrastructure Partners, is producing a standard format which local authorities can use to gather information about small suppliers in their district. And I guess the assistance that we'll be wanting is for local authorities to get an understanding of the small suppliers in their region, and to collect some information from those small suppliers, and preferably using the format that we're going to provide. So that's an important thing. It's an important thing that we would like to work with local authorities on, and understanding you know, there could be up to more than 75,000 small suppliers out there. Working with local authorities on identifying them is something that we're going to have to do. And in due course, we will be engaging with local authorities to work out a process for doing that.
Okay, another one that's been bumped up from Chris Stingle. What do the new dictates, rules, mean for storage facilities, i.e. tanks?
Interesting question. For small suppliers, we haven't really included any specific rules around storage. And the reason being that most small suppliers don't have a lot of storage, and we think it's covered by the Water Services Bill general requirement to provide safe drinking water. If you're a large supply, we've set a number of rules around storage facilities and how they have to be managed, and that kind of thing. I guess there's some general rules that apply to all suppliers, and one of them is protecting the water. So, for example, equipment used on water supply shouldn't be used on wastewater systems, and the disinfection of equipment, and people going into reservoirs and those kind of things. So there's some general rules there that will cover it, but not any specific rules for small suppliers.
I'm conscious it's 5 o'clock and our hour is up. However, I see there's still a lot of good questions in the Q&A. So if the panelists are happy to carry on for an extra 10, sort of 15 minutes, I think we'll carry on through the questions. But in case people are starting to leave, thank you all for your panelists, for your time. It's been a really thought-provoking question. And I have put in the Q&A box just for anyone who hasn't had their question answered or thinks of a question on later on tonight. Please do email through to newzealand@siwem.org, and I'll pass on those questions to any of the panelists who will get back to you. So continue with the Q&A. It's fascinating. Thanks, guys.
All right, a couple more that have been bumped up there. Another one from David Adamson. Pete, peak flows at treatment plants and cost to install.
So excuse me, the two we were talking about on Waiheke, Matete car park was a 5 megalitre a day, and that was 152,000 with a dual stream system. And the one at Onitangi Sports Ground was a similar sort of size, but we only had a single stream for that one, and that was the 132k. So it really is a case-by-case basis, and understanding the chemistry is key to that, because a lot of the additional cost in that space was around the softening of the water and dealing with the pH, because it just happens to be hard water over on Waiheke. But it's of that sort of magnitude, if you want to meet the standards Jim's talking about, and that's where probably we're going to have to go fairly, very soon.
Okay. One from Sam Williamson. Hi team, will restaurants, factories on bore/roof water be classed as small supplies, please? So 120 packs people, restaurant and beverage production facility, a brewery. And then just to follow on from that, yeah, mostly worried about chlorination requirements, as chlorine is a huge tainting risk in beer production.
Short answer is yes. Anything other than a domestic household is what the government has put in the Water Services Bill. So short answer is yes. In terms of tainting, there's a couple of things around that. Carbon filtration to remove chlorine is one, and the other is that the Water Services Bill has a provision which allows people to seek exemptions from residual disinfectant, and so there is that option of seeking an exemption if you feel that chlorination of a water supply is a problem.
One here from Michael Goldingham for myself and Pete. Have you ascertained what the impacts will be on your respective areas with the coming of Taumata Arowai? Things like operator qualifications required, compliance reporting, etc.
That's actually probably a good one for me, guys.
Great.
Yeah, so from day one, we built into our contracts that the contractors that were successful would need to comply with drinking water standards in terms of operator qualifications. Hence, we targeted contractors that we knew, basically from our own backgrounds, working in the industry for quite some time. We knew we were targeting selected tenderers who could do that. But again, it's written into the contract documentation that they must do. Obviously, over the 4 years, we've had the situation where operators within the contractors' teams have moved on and new people have come along. And both our contractors had no hesitation in making sure that the training is undertaken, and in a couple of cases I've initiated training for our own staff within the small waters team, as well as for the new people in the contractors teams. And we've done that collaboratively. We've had both contractors, staff, and our own people all in the same room. We've had OPIS training come and do some of that for us. And in terms of the compliance reporting, we are partway through a telemetry program. Now we're capital program and operational program where we've got monitoring underway, so that we'll have automated reporting. We'll have a dashboard set up, or we do already have a dashboard set up, where we can view results, and automated reporting is being developed now, so that that's all, it's all simple. There's a fair bit of it done manually at the moment, but yeah, going forward, we'll just work with Taumata Arowi. The requirements most likely will change, but we'll work with them, and we'll ensure our contractors do as well.
Cool. All right, one from Alan Evans. Volunteer operators now face heavy penalties if any failure. How can we cope with this, or I guess get help with this?
I mean, I can answer that. Yeah, this has been asked of me several times, and it's about liability. And I think the key thing to remember is that volunteer operators, whether they're volunteers or paid, are liable now, and they always have been liable for the provision of safe drinking water. So nothing changes with that. Yeah, there's penalties, but there always has been. So that's not actually a change.
Okay. One from Matthew Blinfield for myself. What's the availability of Usgpa validated UV systems for small flows? Typically in Australia, these seem to be for only around 5 litres a second and up. I mean, our Hanovia branded systems, we've got small Usgpa validated systems down to probably a practical operating range of about 50 litres a minute. Quite small. I guess one of the tricks there is around the cost. So you know, a typical difference, like, you know, sort of rule of thumb cost between a NSF validated and a Usgpa from the products that we supply, it might be 3 or 4 times the price. So you know, there's obviously a consideration there. You do get what you pay for to a degree. You know, the Hanovia systems are generally very good quality, but yeah, there's definitely a cost factor there. And another one from David Adamson for Jim. If a water supply complies with the rules, where does responsibility for performance sit?
Yeah, interesting question, and thanks for that, David. Responsibility for providing safe water always sits with the water supplier. It's not Taumata Arowai's responsibility. And you can have a situation where a water supplier fully complies with the rules, but still provides unsafe drinking water. And that's simply because, you know, let me give you an example. PFAS, you know, firefighting foam contaminating water supplies. When that all occurred, there was no MAV for PFAS, and no one was testing for it. So these new things emerge, and we don't have rules for everything. So at the end of the day, it's always the water supplier's responsibility, and that's reflected in the water services bill, which is very clear that a water supplier has a responsibility to provide water that's safe to drink.
Great. One from James Corbett. Do you think the legislative framework for the protection of groundwater is sufficiently robust or requires improvement? How are you managing issues with land contamination in the vicinity of supplies? How are risk assessments being carried out?
Yeah, so perhaps I'll answer that as well. There's a couple of things there. One is there's a new NES for sources of human drinking water that MFE is producing, and that requires water suppliers to undertake some work to determine risks. The other part of that is the Water Services Bill requires a water supplier to prepare, as part of their water safety plan, a source water risk management plan. Exactly what that looks like is yet to be fully determined. We're doing quite a lot of work on it at the moment. Do I think that's going to be enough? The simple answer is we'll see. I think we just have to wait and see how both of those things pan out and what they look like, and that'll give us an indication. But it's all new requirements on water suppliers, regional councils, etc., etc. So yeah, let's wait and see.
Okay, great. So we've got 4 questions to go. Should have enough time to get through those. Yeah, another one from Tyler McMillan there. The language being used, unsafe to drink. Who is deciding what constitutes unsafe, and what is the definition based upon?
Yeah, good question as well. So look to the Water Services Bill. It has a definition of safe drinking water, and from that you can work out what unsafe might be. So that's all written into the Water Services Bill.
One from Les Newman. Also involved in another water supply to a small village, which we supply non-potable bore water. Are we caught up in the new rules?
Short answer is yes. It's not acceptable to provide drinking water that's not safe to drink or non-potable, and I would advise that you'll need to seek some assistance from a clever person like Ben to help you work out what kind of treatment system you're going to need. But the provision of non-potable water is not going to be acceptable.
Another one for Jim from Mark Rowe. Do you see any change to what is presently covered in the regional council water take consents? Will the water quality aspects sit solely with Taumata Arowai to regulate?
So Taumata Arowai doesn't regulate fresh water. We regulate treated drinking water. And so the regulations around freshwater quality still sits with regional councils. Will it have a different have an effect on water take consents? I think you'll find that the NES for sources of human drinking water will have an effect on consents. There's some requirements there that will affect consents. And I think that the Water Services Bill requirement for source water risk management plans, there's a requirement, or there's been a lot of talk about regional councils needing to take account of those source water risk management plans when they're issuing consents. So yeah, I think there's a bit there for regional councils to take account of when they're looking at water take consents.
Okay, one from Sean Perry. When will you be able to go into more details in what the minimum requirements are for these small water supplies, i.e. analytical requirements, etc.?
Yeah, that sounds like one for me again. And I would like I'd like Sean to be able to send you these rules tomorrow so that you'd know. But I work under a whole bunch of constraints, and I would expect that as soon as once the Water Services Bill is passed, as soon as possible after that, we intend to release the rules for small and very small suppliers and large suppliers to everyone so that they can see what those rules are like and get a bit of a feel for them. And then probably sometime early next year, we'll go into a public consultation process. So yeah, I'd just say wait, we're going to give everyone plenty of time to see them and plenty of time to comply. So we won't be telling people you've got to comply with these rules straight away. There's quite a long lead-in period in the Water Services Bill. You know, it's at least 5 years. It's 5 years at the moment, and that's under further consideration. Small water suppliers won't hear much from us for the first 2 years. We'll have our hands full with local authority suppliers, but after that, there'll be quite a big engagement process, and it's not going to be a case of Taumata Arowai saying, right, you've got to comply from now, and if you don't, we're coming around with a big stick. That simply won't happen. That's not the kind of organisation we will be. We'll be making very clear to to small suppliers what they've got to do, and we'll be giving them plenty of time to get up to speed.
Great. And the last question from Matthew Bloomfield, which I can potentially answer. As a reference point, a 5 megalitre per day reliably through cartridge filters must be some amazingly clean water with virtually no TSS. You'll not get change out of $5 million for a 5 MLD surface water treatment plant in Australia. I think the trick there is the size. I'd be guessing that a 5 megalitre per day plant would be above what we're talking about around the smaller supplies. I think that sort of jumps into the sort of medium supply. So I don't think cartridge filters would be essential for a larger plant like that. You sort of get into the realms of meeting your compliance through media filtration and online turbidity monitoring and things like that. So I'm not sure whether the sort of cartridge filter requirement would apply at this level. And I think that is it. 5:15, not too bad. I'll just pass back to Tom to close out if that's okay.
Brilliant. Well, thank you all to the panelists. Thank you everyone for dialing in today. Yeah, particularly Jim for all those questions coming your way during the Q&A session. But thank you to all the panelists for your insights. It's really interesting to hear from that kind of what's being required of us all, and then the actual practical going forward. And obviously this is a space to watch going forward, which we will do, and we'll wait for the bill to come through. So unless anyone has any final wrap-up thoughts, I'll say nope. Right, well, thank you very much, everyone. Kia kaha, and